DevOps. Now this opens up a whole new section of the content because I kind of want you to think about this as an engineer. You usually won't set the tools, but the blockchain being distributed actually sets up some really interesting stuff and ideas around development and around engineering, especially if you're in something like Hyperledger or you're using a permissioned Ethereum or whatever. You have more than just one person. You have scalability issues. You have a bunch of things that from an engineering viewpoint and a development viewpoint are actually really kind of fascinating to kind of take a look at. And that's what we're going to kind of talk about on this one. Now, you're really going to want to do a full-blown DevOps process, in all honesty, even if you're just doing a distributed application for yourself, just because you're going to be able to deliver your product a lot better. So there's always something about having a formality or a formal business logic workflow for whatever it is you're doing. And DevOps gives you that for when you're building your business for software development. So that's really kind of that important part, right? There's some really important considerations, whether you're building a DEX or a SEX, or you just have things you need to take a look at, like you can't pull old code from the blockchain. Once it's on the blockchain, it's there forever. And you're using Ethereum or Hyperledger or whatever as your computing platform. So now you've got a bunch of things you need to worry about. Upgrades. How do you make sure that people are using the latest version and all these other things that kind of go into this? So from an engineering viewpoint, it's really a fascinating problem to solve, right? So what is DevOps? In case you haven't heard of it, I'm going to assume that you know a lot about this already, right? Is that basically it's CI/CD, continuous delivery, continuous integration, continuous development, continuous processes for people, processes, and products, right? So DevOps is a business process. Essentially, it's a business workflow that allows you to go from idea and code to a fully released project. And it has a bunch of firmly embedded software development practices in it that will make your life a lot easier to develop good quality code and deliver it on time. There's also a really cool subset for Sec DevOps, especially if you have people in your security department that can program. Wow, this just makes your life a whole lot easier, and how to bring your security team in on the coding practices early. Now, as far as I know, it's a hard time trying to find someone in security that knows how to code. Even I'm not great at it. I just kind of know what I'm doing every once in a while if I'm really lucky. But Sex DevOps is really kind of a neat thing to have along the way. Now, really, as the engineer, there's a lot of automation that you're going to want to set up, or a lot of automation you're going to want to design, especially for deployment, components, topology, and configuration. Now, the interesting part about this is that, especially if you're using a managed service in the cloud, there's some things you don't have to worry about here. So if it's a managed AWS or a managed Azure through their subsidiary or their partner, they're going to automate that environment for you. So those are things you don't have to worry about from the product on forward when people are using it, but from product on backwards to idea, you're going to want to automate your testing. You're going to want to automate your processes that can be automated, right? Especially as you're checking in and checking out code, repository size, configuration, topology. There's a lot of cool things you got to do here because you really want to make sure that there's no real manual changes without being recorded or without being noted. So the other thing that makes DevOps more interesting is usually you don't have a multi-party nature in your application. If you're doing a distributed app or you're part of a consortia, now you have to take into account everyone other company's business process and way that they do software because they may not have a formal process around it. DevOps gives you a good floor for doing that. So kind of cool. It just all depends on what kind of a project you're working on, but it really makes it a lot happier. And there's some questions that you need to ask from the engineering viewpoint, even just from the developer viewpoint, right? These are all questions your program manager should be asking, because who gets to do what in this environment? If you're doing this in the cloud, and I tend to do a lot of things in the cloud personally, that's where my strengths are. Who gets to do what? Who gets to release code? Who gets to develop code? Who gets to do code reviews? Who gets to integrate new stuff into the code? All these things that go along with it for the organization. And then if you're working as a consortium member, how do they set all their stuff up? And can you agree to that, right? So you've got a bunch of rights, you've got a bunch of processes, and you have to have a way for those rights to be managed at different levels of the solution. All right, and I mean that. You have platform rights, Because if you let your developer just spin up an Ethereum node because they can, remember it's about $200 to $400 a month, depending on what they spin up, right? Any kind of infrastructure. Well, if you're doing a managed AWS or a managed Azure solution, you don't really have to worry about the infrastructure, but you will worry about your smart contract and how do you get it into the test network, and then how do you do all these things? Who gets to do that? Who gets to make a pull request? Right? People will have their code stolen all the time. It's not an unusual thing to have your source code stolen. Just look at Okta today. They had that happen to them. So who gets to do what, and then how are you going to protect it around the edges, right, to make sure that it can actually happen? So who can approve a pull request, and then how are they approved? Minimum number of members required to approve a request. So remember, you just don't want me coming in there and saying, oh, this looks like great code, and start tinkering around. I'm not the person to do that. But you don't want me doing it because I think I know enough to be dangerous, and I probably would blow your project up, right? So minimum number of members required to approve a request. And then think about it. What happens if that person goes on break? Who's their alternatives, right? Can different members' votes be weighted differently when you start getting into that whole DAO process or governance process, right? Remember, if you're in a consortia and you go pull out that poll and that voting, that's something you need to work out from the programmatic viewpoint. How about if all the tests are successful? Can approval be automated? So if it passes all of its tests, can it just go straight into production? Or do you want to have one last final code review? Considering that consortia can often span time zones, right? The sun never sets on some of these software companies. How do you determine deployment timing? You want to centralize around Greenwich time, Universal, UTC, or do you want to do it in some other way? Identify and prioritize and deliver hot fixes. Now this is kind of interesting because you've got a code set in the ledger that can't be changed, but you find some flaw, some error, some hideous thing that you need to fix. How do you deliver a hot fix? How do you get that issue out and get it fixed fast? What's your SLA? What's your policies? How do you solve all these problems, especially in a consortia? Right? That the consortia makes things a lot more complex. But what's really kind of cool is you can automate some of it depending on what happens within that consortia membership and voting. You're just going to be the one that sets up all the infrastructure to make it happen. The other thing that makes this interesting too, whether it's a DAO, whether it's a distributed application, just a standard one, or whether it's a consortia, man, who controls the wallet? That's a big one, right? Who actually controls the final wallet on this thing? Who has access to it? Who can just withdraw funds if they need it? What's the multi-signature process? If you have an automated process and you have a smart contract interacting with that wallet, do you have a multi-signature process for that? Can you do it fast enough? Now, the cool other things that you got to take a look at for that ownership and responsibility is how do you integrate with third-party systems like Oracle data and other stuff? If you're working in a hybrid environment, permission public, now you have to stand up a whole Active Directory or LDAP process, and you have to connect that in with what you're doing on the permission side as POA. There are proof of authority modules for consensus. So you've got all these things, right? But now you need to set those up. And you don't want to just let the developer or the security guy do it. You're the engineer here. You're going to be your process to design and set up and build. You may have bits and pieces, but then how do you control that data as well? What are your permissioning around testing data, security, other process data? And I mean, all this stuff is high value. If I have your bug report, thank you for doing my job for me, right? From a hacker viewpoint. And then who owns the business process? Who ultimately is the person responsible for that whole business logic, right? And then key management. Again, lots of neat things to think about. Keys, key management systems, how you're going to set it up. If you're doing it in the cloud, do you want to use a native KMS, or do you want to have your own CA where you're managing the keys? How do you get those keys shared across a bunch of consortia members if you're doing a standardized AWS account and people don't want to be in AWS? Again, lots of things that go into this. The thing that's other kind of cool too is you're going to need to set up a quality assurance environment, a QA environment. You need to have set in processes, and you're going to need to have these things documented, right? For testing shared assets, testing third-party assets, especially if you're going to test stuff that you're bringing in, things from like OpenZeppelin or others. How are you going to involve QA, security, third-party audit, and others? So you're going to have third-party audit come in and take a look at your code. How are you giving them permissions? How are they going to connect in? Are they going to remote in? Are you going to force them to come to the office and take a look? Do you have a VPN? Do you have a VPN concentrator? Can you support remote access? Can you support SSH? You know, what are you going to need for code testing? What do you need for security? What do you need for transparency? And these are cool problems because now you have this whole other team over here called QA, right? You need to also set the scope of release, timing, once the code has passed all the checks, whether you're going to do an annual or quarterly code review, and then regulation. Regulation will tell you you have to do a lot of really cool things, right? So if you have health information inside of your blockchain, even if it's hybrid or private, you still have to meet HIPAA compliancy. So how do you comply with those regulations? If you are working in a DApp, you're working at a DAO, you're doing a bunch of the cool stuff with money, man, you've got a lot of financial things you need to suddenly become compliant with, right? And you also have to be able to bring in and blocklist wallets and all the other things that would go along with that. It makes for a really interesting day when it comes down to how you connect all these things. The other thing too is smart contract design. The actual design may require that you open up stuff on your firewall, or may require that you do other things to track all the processes and other configuration changes that need to happen on the development side. And that's, update them as necessary. That you should be not static on how you set up your DevOps. If you find a better process, a better way, you should do it. A lot of people really prefer simpler smart contracts over large ones because you minimize the set of problems that are done. But each smart contract then becomes literally its own function, right? And it's being called from all over the place. Now, how do you support that from a network engineering viewpoint, right? It may all be in Ethereum, but you've got to set up that test environment and you've got to work inside that test environment, but you also need to be able to test locally. So how do you handle all those calls back and across the network? What ports are you blocking? You whitelisted and all this stuff. How do you tell the difference between smart contract testing and smart contract hacking, right? Now, the other thing that's interesting too, and this is one of the things that they talk about, especially things that require complex math, right? Inferred states, keeping them off-chain. Now you need an off-chain data repository that can be accessed by the on-chain data. All right, how do you push that on-chain, off-chain data with trusted oracles? How do you do all this stuff? How do you set it up? As an engineering person, these are really cool problems, right? Audited production test library contracts, again, things like OpenZeppelin really help out. Standards, how do you bring all that stuff in? If you're going to call stuff from OpenZeppelin, you're going to have, when you're testing, especially testing locally, you'll see a lot of traffic going out to them, right? Make contracts testable with a limited set of dependencies. So that means from a design viewpoint and engineering viewpoint, you need to know what those dependencies are so you can engineer whatever solution for the network or for the components while you're in testing. Right now, admitted, you'll probably be testing on Wrinklebee or Gurley or somebody else rather than on mainnet if you're on Ethereum. But you really do need to, during development, do all those processes so you understand how that contract works and what it looks like on the network, because you're going to end up monitoring this contract and you have to be able to bring all that monitoring data in. The more from the engineering viewpoint, so you can build dashboards, you understand how that contract works, the easier it is for you to build the dashboards, to do the monitoring, to set up the security alerts, to keep track of what's going on with that contract. Now, peer reviews should be conducted, right? Especially towards unnecessary complexity. And as an engineer, you should be in there. Hey, do you really need to do this thing? Or why are we doing this thing? Or where does this thing go? Now, ideally, you'll also have some smart contract auditors that can probably help you out from the engineering viewpoint as well. Auditing, QA, developers, security, and engineering should all be working together happily on this project. Now, if you design your contract really super simply, I want you to kind of think about it. What you're doing, you're setting up a series of functions. So essentially, you're doing microservices or you're going into a cloud native format. And that actually makes sense for Ethereum as a global computing platform. If you think of Ethereum like it is its own cloud in its own way, it's just a distributed cloud, right? It's not set up on central viewpoints like Amazon or AWS or Google. You don't have a data center. Your data center is the world. You're setting up your code, your smart contract to be more cloud native. You're working in a microservices environment. You're setting up the libraries that you would be using and then how you control that stuff. Now, again, OpenZeppelin makes things a lot easier. ChainStack makes things a lot easier to go along with this process. But now you have to have a different set of thinking. And from an engineering viewpoint, you are now working in the cloud. You're working in a global compute platform. So from that, you now need to think about how you're going to upgrade contract over time. How do you make changes to hard-coded wallets? Please don't ever do a hard-coded wallet, especially if that hard-coded wallet gets put on a blacklist. If all of a sudden you have your entire liquidity pool put on a blacklist because of the Securities and Exchange Commission, wow, what do you do with that? All right, how do you make that work? So what you want to do is set these microservices up so that they can evolve over time to make it easier to version and document versions of those. And if you kind of think about distributed contract management from that viewpoint of a global compute platform, microservices and cloud native programmatic design for your smart contract actually turns into something really interesting. The question is, do you want to tuck those back and keep those off chain, or do you want to put those into the chain so that other people can use them, because other people will use your contract as well, right? Use role-based access control. Man, I love role-based access control because you're going to be doing things along the way, especially in development and test and QA, that you're going to have a repository. You're going to have synced developers' environments. You're going to be using tools like Jenkins, Maven, Docker, tools native to Google, Azure, AWS. All these things to write and produce code using DevOps processes. And, you kind of need to have the whole back-end infrastructure to support all of the roles and access and permissions and everything else around that. And then you need to make sure that if you pull those libraries from OpenZeppelin, that others can use those and set those roles up and assign ownership around components if you can get to that level of discrimination, or you want to. You may just say, oh, I trust all my developers and give them admin access. But when you start syncing things down so that you can make sure that everyone can use the contract on a minimal permission set, making sure everyone's got administration access just doesn't work, because things will break. When you're doing automated testing, you're going to have an entire engineering environment around QA and test. Especially, it's important that you have a different environment. Now, you may be working in Ethereum, you may be on one of the test nets, and that's okay, because you're still going to be doing stuff locally, right? You're still going to be writing tests. It's important to assume that you're going to find stuff to fix, and it won't be the author of the code that fixes the problem. It may be a security person. It may be a QA person. And again, the hard part is going from a blank page to operational code. The easy part, the easier part, is looking at someone else's code, taking the test output and going, okay, this needs to be fixed, and then going back and making sure it can pass all the tests. Because if you break the code, you may need to go back to the original developer. But most of the time, it's going to be someone else who fixes the bugs, right? Now, you have to give fast feedback. So when an error occurs, those tests should execute quickly, and then your feedback should show up. It doesn't mean that it happens that way. It means it should. So your test specification should define what's being tested, why it's being tested. Your test harness is going to be highly readable, and you should be able to determine exactly where the fault lies in the failing test. And then there's a lot of communication back. And as an engineer, you're going to be building that automated testing infrastructure with your QA and your development team, and hopefully your security team, so that when you have a failure, when something breaks, you know what test it broke on. Making sure each test just can execute independently. Again, go back to that cloud native, that functionality where everything is distributed as microservices. And then make sure you're covering all the branches of that contract logic, especially if it goes off on a tangent, someplace you didn't expect, because that will happen. You get to build that environment. It's really kind of cool. So there's going to be assertions that assure that things that happen, and things that shouldn't happen, don't happen. Now you have a lot of communications. You have a lot of data. That data needs to come back to your QA and your developer and your security. They all need to be able to see it. They need to be able to understand it. They need to be able to go into the code base and do whatever it is they're going to do. They need to be able to assign priorities. So if you get into something like Atlassian and Jira, you know, you have all these things that are going to be fun to integrate and put together. So have fun with this one, right? All of this needs to tie into the CI/CD testing process, all of it. So that means you're going to be trying to set up systems like Truffle and Ganesh as part of your automated testing suite, because odds are highly likely Truffle and Ganesh are basically the two standards at this point, right? Whether you're in the cloud, a local test suite, you want to make sure that all your tools can run accurately, and that's going to be tied to role-based access control, and then making sure that data is available to everybody, right? You're going to have wiki systems, so documentation and sharing. You may have a Slack channel. You may have a Discord. You've got all these things, right? You're going to be bringing in some really good agile or Scrum processes. You may be tracking via Kanban boards, and all of this stuff can be tied to both manual and automated processes. It's a fun engineering project, right? And again, DevOps just makes it easier because you got to think about the whole thing. Now, your environments, right? What kind of environments do you need? A local environment, the desktop, whatever the developer needs to make sure that they can do the job the way they want to do the job. Now, the other problem comes in place when you have consortia shared test environment and maybe a consortia production environment. How do you tie from all of these private groups? How do you tie to a single infrastructure for this project? And then whatever your pipeline environment is, from test to production and release. Your release, your final end goal is going to be getting it onto the Ethereum network or some other network that handles smart contracts. But how do you go from idea to that whole release system and making sure that whatever you designed is the best that you can design? So engineering wise, building out a CI/CD DevOps system is a ton of fun. It really is. It's an interesting engineering challenge. It's a really interesting challenge to do all these things so that you get everything set up well, so that you can just let your developer go from idea to production. And they have all the support that they need to get there. And as an engineer, that's going to be your role, right? There are bigger items in this process, so you're going to have some scaling that you do need to do, especially on the test suite and on the test side of it, right? Especially on repository, whether you're using Cloud9, whatever it is you're using, right? If you're using a managed blockchain, some of that scaling will happen automatically, and that's cool, but you may just need to do other things, like maybe spin up a second or third or fourth Ethereum node, right? You may need to do these things. You really want to give developers QA security and program management, all the things, right? From Scrum, Agile, all the way through Kanban, all the way through automation and testing, all the things that they need to have so they can get that feedback, whether it's coming from person or automation or wiki or Slack, for the engineering team and the developer team to build out that infrastructure. So it's just kind of cool. So if you've never worked in a DevOps environment, a formal code programming environment, this really makes it a lot more fun to work with. You get to do some really cool stuff here, and then you get to see your code kicked out to the world, and you get to see people start to interact with it when you go into monitoring. So that's it for this lecture. I hope you've really enjoyed the DevOps lecture. We'll go into DevOps security next, and I'll see you in the next lecture.